Web3 development still looks like this: 5 disconnected tools, an AI that can only see text files, and zero awareness of chain state. Crucible puts everything in one place and makes your AI agent the developer. Each workspace gets its own Hardhat node, a real terminal, and pre-funded wallets. No MetaMask, no port forwarding. Sign in once with Ethereum. The preview is a real dev server, wallet injection, live contract, all in one tab. As you can see, we can choose any models. Now let's try zero-G compute. This has sealed inference and attestation hash on every turn. For complex code generation, we can switch to a more capable model, but always transparent. And as you can see, the transaction hash is there. And then we switch to a more complex model. Everything happens inside the single tab only. There's an editor, the entire prompting is fully visible. And as you can see, the new re-entrancy guard has been implemented by the model. Now let's move on to the flagship feature, that is self-healing agentic loop. We tell the agent, it snapshots the chain, traces the revert, patches, redeploys. So as you can see in this one, we hit a bug when we were trying to withdraw. Now we try to prompt the agent to fix it. The agent starts the node, compiles everything, tries to deploy it locally on Hardhat. All the tool calls are deployed through multiple MCPs in our architecture. This reduces token, and yeah, there we go. A revert has been detected, which triggers the self-healing loop. Now the model will try to trace all the transactions with our harness. It tries to recall memories that are already present or broadcasted by other nodes. This is a feature of Jensen that we will go into more details later on. There we go. It has applied a patch and now it's trying to withdraw the funds again, but there's another small bug that was introduced on purpose. Now it enters into one more agentic loop, then tries to remember things again, but as you can see, there is currently no memory as this is a very new workspace and we haven't seeded anything yet. Now it has found the fixes and applied them. And now that it has applied all the fixes, it remembers them in its own workspace and shares it over the mesh with other Jensen nodes. So currently we have only created 3 memories for the 3 bugs that we faced in this. And now if we try to withdraw, the wallet UI appears and then we can easily extract our transactions. There we go. Next up, we are going to talk about the memory storage. Okay, the Keeper Hub storage, and yeah, contract has a, so we are trying to set up a Keeper Hub automation flow, and by deploying this to Sepolia. So we have also added MCPs for deployment on different test nets. So there we go. The contract has been deployed. Then we go to the Keeper Hub URL as soon as it's created. There we go. It's live now, and we can go check into our Keeper Hub dashboard. It has appeared. There we go. Now for the memory part, we have now seeded this Crucible workspace with multiple memories from different mesh and different nodes. So you can see all the memories that have been saved by different workspaces over the lifetime of things. So this is a ERC20 contract, an OTC contract, bugs. And for zero-G, we can always just deploy to the zero-G testnet as well through the agent. This will also compare all the existing memories to make sure that there are no bugs. Yes. Thank you.